Hi, my name is Leon. I'm a software engineer here at KDAB, and in this short course, I'll show you how, in just 3 easy steps, you can get to integrating Rust into your Qt application. This will also serve as an introduction to CXX Qt if you haven't heard of our new library yet. So, before we talk about how to actually integrate Rust into an application, let's first talk about why we'd want to do so. First off, Rust has very good memory safety by default. You don't have to worry about, for example, a use after free or uninitialized data that you might encounter frequently in C++, and which can lead to corrupt data or even a crash in the worst case. And a good example of this is the Chromium project, which estimates that around 70% of their security bugs stem from memory safety issues. And those could have been prevented by just using a language like Rust. The same goes for multi-threading, where Rust is very safe in comparison to C++. And that also makes it very easy to multi-thread because you're protected against data races that can cause very hard to detect errors that can be really problematic. And we also get a great generic system that is based on what Rust calls traits. And that's somewhat similar to the concepts available in C++20. However, Rust already has them and uses them by default and makes them available everywhere. Rust also improves on dependency management by giving you a really easy to use dependency manager called Cargo that lets you integrate dependencies in just 1 or 2 lines of code. And we don't even lose in the performance department with Rust. It is just as bare metal as C++ is, and can therefore give you the same exact performance. But now that we know that we want to use Rust, where do we actually want to use it? Because we always want to use the right tool for the right job, right? So in my opinion, I think we should actually stick with Qt and especially with QML for the design of our GUI, especially because it has just this very fast iteration. It's very declarative and very easy to use. And we don't really want to lose that, right? So there is another part of basically any Qt application though, and that's the business logic. And that is usually written in C++. And this is, I think, where Rust is a perfect fit. Because Rust offers you a very strong type system, the performance that you need for your business logic, the same as C++, but it also offers you much more safety than C++ does, for example. So now that we know that we want to use Rust, and we also know where to use it, how do you actually get to mixing Qt and Rust? Well, there are basically 2 approaches that are typically used. And the traditional approach that most libraries tend to take at this point actually just create bindings for the several Qt functions to be available in Rust. So Rust basically directly calls right through the language barrier into Qt and C++ code and functions. However, this has a few problems, especially because Qt is inherently unsafe from Rust's perspective, and is also very object-oriented, which Rust just isn't. That, in the end, ends up making the Rust code very non-idiomatic. You sometimes even lose some of the safety guarantees that Rust can provide you if you have to then start again to deal with pointers, for example, from the C++ side, which are just inherently unsafe, and Rust can't make them safe. So how do we get around this problem? Well, here at KDAB, we've built this new library called CXX Qt, which builds on top of existing work that it doesn't just allow Rust and Qt to interact, but Rust and C++. And one of the great projects to come out of this work is the CXX project, which creates a safe C++ and Rust subset that can be used to communicate between Rust and C++ safely and idiomatically on both sides. On top of CXX, KDAB has built a new library, CXXQ, which then can allow you to safely interact between Rust and Qt by defining Q objects in Rust. This, in practice, works by creating a module in your Rust code. And a module is sort of similar to a namespace in C++, where you'll then describe what you want your Q object to look like. And you can then split it up into two parts that give you a very clear separation of concerns. The first is the Rust part, which is generated by expanding a macro on the Rust side. This can create a struct called Rust object, which is the Rust representation of your Q object. And this can contain additional data that might only be available to Rust and might only be safe to use in Rust. It can also contain all the Rust code. And the second part then is the code generation that can be done automatically from the Rust module to create an entire subclass of Q object. Currently, unfortunately, only Q object. So if you want to define a list model, for example, you'll have to wait until we get that feature into CXXQ. But we will get that into CXXQ at some point. That automatic code generation for the C++ side can then be the basically Qt side representation of your Q object. These two representations can then safely interact using CXX. And because we're using CXXQ, we can also use some wrappers that we have defined for the common C++ Qt types like QString, for example, that can then seamlessly be transferred into the appropriate Rust types. This then just results in very clean, very idiomatic code, both on the Rust side and also on the C++ side. Because in the C++ side and in the QML side, all we're doing is basically defining just another Q object, like we do with any other, and we can then cleanly interface with existing C++ code and existing QML code, for example. So now that we've seen how this works on a conceptual level, let's get to actually writing some code. What I have here is one of those modules that I talked about earlier. In this case, this is indicated by this mod keyword in Rust. And we want to now create a Q object subclass called just myObject. That we do by using this makeQObject macro to then expand the myObject module into all the code we need. And to know what data we'll want on the C++ side, we can then define a struct called data that contains, in our case, a number and a string. This data will then be generated into that C++ Q object subclass that I described earlier, that will then contain a number and a string, and those will be just normal Q properties. They'll have setters, they'll have getters, they'll notify whenever they change, just like you would with any other Q object property. But what we can also do is this part down here, where we define a struct called Rust object, which is our Rust side representation of our code. This can have additional data. In this case, it doesn't, because it doesn't need that, because it can interact with the C++ side. But it does define two functions. One to increment the number that's part of our struct, or our Q object. And this then just takes the CPP object, which, just like the Rust object, is the Rust representation. The CPP object is the C++ representation of our data. And that, therefore, has access to both the number that we defined earlier and a setter for the number that we defined earlier. By using that, we can just like normal increment our number on the Rust side and set it using the setter that we're used to in C++ QML code, which will then, of course, because this is a property, also emit any signals associated with that property. Just like we can mark a C++ function as invocable, we can also mark Rust functions as invocable. And in that case, they'll also be accessible from QML and from C++. And the same goes for the sayHi function that takes a string and a number and then just prints the string and the number. In this case, this will be just the string and the number in our Q object. Now that we've described how we want to use, like what kind of Q object class we want to generate, we can then go into what is called the build script in Rust that then does the code generation for us, where we just add the file we want to generate from, and then just builds the C++ classes. And once we have those C++ classes, we can go into the C++ setup code that we already need for Qt, use the header that was generated for our myObject subclass, and then register that type to be accessible in QML under the name of myObject. Or we could just use it as any other C++ type, because again, this is just a normal QObject subclass. But once we've registered it for QML use, we can then first import it and then instantiate a myObject. This myObject can then, just like any other QObject, can have a number and a string. And we can, for example, use the properties with data binding. This will just work. So it will always display the correct number in the string. To prove that, I've added the label for the number and the string, and two buttons that also interact with our two invocables that we defined earlier. Our invocable to increment the number and our invocable to sayHi, so to just basically do some computation from the Rust side. Now that we have our example program, let's run this program. And after building this, we now get our number and our string. And we can, for example, increment the number, which is done in Rust, like we've defined it earlier. And we'll see that both numbers will update accurately in the string and in the number. We can also call the sayHi method that we defined in Rust earlier. And this will then say hi from Rust. And we can, of course, increment the number again and say hi from Rust again. And we'll see that we already get the updated number in the Rust code. All right, now that we've seen what CXX Qt can do, how can you get access to these features? Well, CXX Qt is just available on GitHub. It is even published under a very permissive MIT and Apache 2 licenses, so choose your license. It's free and open source software, so you can use it in whatever project you like. However, we should warn you that CXX Qt is still work in progress. Things are subject to change, so we don't really recommend using it in a production system yet. However, we really welcome any contributions and suggestions of how to take this idea further and develop the best solution we can to interact between Rust and Qt. Well, if you've made it this far, consider subscribing for even more Qt and possibly Rust content in the future, and let us know your thoughts in the comments below. Thanks for watching. Bye.